And take 3. Everything is just coming up Millhouse here today for me. Great. So this height is adjusting. Let's see if we can get this done here. I just have this question to finish and one more. We are so close to being done. So this height here is going to be 1 minus y squared. At this point, straightforward. Calculus with some antiderivatives. One half minus 1/4, which is going to get us a 1/4. All that's going to get us pi over 2. And if you want to go back and look at the first question when we did it with the disk method, it's also going to be pi over 2. Not going to risk that it's going to shut off on me again because it just wants to. So we got one more question here. And reading this, find the volumes of the solid obtained by rotating the region bounded by y equals x minus x squared and y equals 0 about the line x equals 2. What's different here is we're not rotating around an axis anymore, but actually around a line that's kind of just out in the open. Let's see where to actually graph this thing. So first thing is let's set this equal to 0. And we see it's going to happen at 0 and 1. And this is a parabola, right? It's got an x squared, so it's an upside down frowny. It's just going here from 0 to 1. And we're rotating around the line at 2, which means we're going to have another gap kind of over here. So this was 2. That means this is 3. This is 4. 3 and 4 are not really important. Yet again, if you're trying to determine whether we're using shells or disks, it's obvious that we're using shells here because we're in the shells chapter, but it's not always that obvious. The reason you know it's going to be shells here, though, is we only got one thing. There's only one physical function here when we're setting this up. If you slice it this way and you're trying to do the disk method, you're just trying to do the same function upon itself, which is going to cause some issues, as in can't do it. Whereas here, with some shells, it's definitely going to help us out. So let's see. We need our bounds. It's just from 0 to 1. Nice and simple like that. 2 pi. Radius here is a little different. Think we're not spinning around an axis anymore, but we're spinning out around a line 2. So at some point, one of these shells is going to have a distance or a radius of 2, and at some point it has a radius of 1, kind of as we're sliding it in. So we have to be able to set up some function that can go from 2 to 1 according to where we are in the x-axis. Since we're spinning around 2, we just set that as our middle, and you do 2 minus whatever the axis is, or whatever the with respect to that we're spinning with. And since it's x here, because we're around a vertical line with shells, that's what we're doing. Final thing here we need is the height of this thing, and the height of this function is based off of this parabola, and it's just always going to be that function. There is our setup here. Now we can just go through and do some quick antiderivatives here. Although the issue here is we do have to distribute 2x minus 2x squared minus x squared minus x to the third. So really in here we're getting minus 3x squared. If it cuts off at this point, I'm just going to say we're going to know how to do it. Hopefully it doesn't though. Antiderivatives, let's start them up. X squared, x to the third, 1/4 x to the fourth, from 0 to 1. So we have what? Did I mess something up here? I might have messed something up. We should have an x to the third that's positive. What did I mess up? Oh, the x to the third is positive, 2 negatives. Yep, that's going to make the difference here. Great. So we get 1 minus 1 plus 1/4. Sorry. So that's a positive. That was the mistake. So here we're just ending up with pi over 2. Okay, 3 parts for this. Like I said, I will probably post in the comment section and send out a talking point of if we want to have a Zoom to talk about any questions you guys might be having. Hopefully everyone's staying safe, and I will talk to you all very soon.